8.0 times 10 to the 4th kilogram spaceship is at rest in deep space. Its thrusters provide a force of 1,200 kilonewtons. The spaceship fires its thrusters for 20 seconds and then coasts for 12 kilometers. How long does it take the spaceship to coast this distance? Okay, so the first thing I just want to make clear in this problem, something so we can assume, since it's going to be in deep space, the spaceship isn't going to have any force from gravity acting on it. So the only force that's going to act on the spaceship is from the thrusters, that 1,200 kilonewtons. And I have a free body diagram of that on the left to kind of show that. So, yes, let's get started. So our knowns to solve for this coasting distance are that the mass is 8.0 times 10 to the 4th kilograms, the thrusters are 1,200 kilonewtons, the time that the spaceship uses its thrusters is 20 seconds, the distance it coasts is 12 kilometers, and the time it coasts is what we're trying to solve for. So this spaceship is going to kind of experience two different kinds of motion, and that period with the thrusters is going to be accelerating, and then the period where it's coasting is going to maintain a constant velocity. And so we should be able to use that first period to solve for the acceleration using some of our force equations. So we can then use that acceleration in order to start solving for some of the time and velocity stuff like that from our using our kinematics equations. So so that first part is, like I said, just solve for A to use it in some of the kinematics equations, so we can then solve for T during the coasting period. So you have to go ahead and convert kilonewtons just back to newtons, and which is going to be a lot of newtons, 1,200 times 1,000, and then go ahead and divide that by the mass, since we know that the acceleration is going to be force divided by mass. It ends up being that the acceleration during that period in which the thrusters were being used is 15 meters per second squared. Okay, 2. Kinematics solve for the final velocity during the period of acceleration and uses it to solve for t coast when velocity is constant. So yeah, basically what that's saying is just solving for the final velocity in that initial period, and then that final velocity is going to be what the velocity will be for the whole period that the spaceship is coasting, since it won't be accelerating in that period. So the equation I used was the v final equals v initial plus at, and I went ahead and plugged in just that 15 meters per second squared that we previously solved for. We were given the 20 seconds, and our initial velocity was given as 0, and once you do the math, it comes out as being 300 meters per second for that final velocity. So now we're going in, we can now solve for time. So since acceleration is 0, we can use the equation I have shown here, and it's going to just, the 1/2 at squared is just going to be 0 since acceleration is 0, so it's going to just be d equals vit, and then I went ahead and solved for t, which is going to be distance over velocity. And once I plugged in the numbers, converting kilometers to meters, and dividing by that 300 millisecond meters per second that we solved for in the previous step, I got 40 seconds for the spaceship to coast the distance of 12 kilometers. So yeah, that's the end of the problem. Thank you for listening.